All right, we're going to work on finding the difference quotient for a given function. And the difference quotient is this expression right here. So we will work on this piece by piece. I'm going to first do f of x plus h, this part first. Then I'm going to combine it with the original function, and then I'm going to divide everything by h. So 3 steps here. Okay, step 1. Let's see if I can zoom in here. All right, so the given function f of x equals 3x squared plus 3x plus 5. If I plug in where the x is, where any x is, the quantity x plus h, that will be f of x plus h. So I'll take my original and just make space for the expression x plus h. And I'm going to go back and plug in x plus h everywhere there was previously just an x. All right, then I'm going to simplify, and this part of it is pretty easy to simplify. We're just going to distribute the 3, and we'll have 3x plus 3h plus 5, and that's no big deal. That's pretty simple. We've been doing stuff like that already, but this part, we've been doing stuff like that as well, but it's a little bit more involved, I guess you could say, and that's because this is not true. Okay, and I see this often. We do distribute multiplication, like in this case, or well, not there, because you have to do the exponents first. But here, this 3 is going to multiply both terms inside the quantity. However, it doesn't work like that with exponents. What this actually means is x plus h times a copy of itself. And then you would use distribution, or what we sometimes call foiling, first, outer, inner, last. So that would be, x times x is x squared. X times h is xh. H times x is xh. And h times h is h squared. And then we have two of the same term, or they're like terms, I guess you could say, both with a coefficient of 1. And that always happens when you square a binomial. You get the middle term, you have a duplicate of the middle term. So this is the simplified version. All right, now I don't recommend that you do FOIL every time like that. It's fine in the beginning when you're getting used to multiplying polynomials and when you're trying to understand the perfect square trinomial pattern. But at some point, you want to be able to know that as soon as you see a binomial squared, you don't have to expand it and then FOIL it. You can use the perfect square trinomial pattern. So we learned this for a previous test, for test 1, I think, or maybe it was test 2. But I taught you to do the first term squared plus the last term squared or the second term. And then in the middle, you're going to have a duplicate, or 2 times the product of each term. So that's plus 2xh. And if you have a negative symbol there, the only thing that would be different is a negative right here. This one is always positive. The 2 squared terms are always positive, because when you square any quantity, even if it's negative, when you square it, it's going to be positive. So only the middle term sign would change. Right? So that was a review of the perfect square trinomial pattern. And I took the time to talk about that here because it makes, if you know how to do that quickly, it saves you a lot of time. All right, so I can rewrite 3, and then I'm going to write x plus h quantity squared as x squared plus 2xh plus h squared. Then distribute the 3 and bring down the 5. And then I will distribute this 3 into the 3 terms in my first quantity. 3x squared plus 6xh plus 3h squared, and bring down the rest. And then see if there's anything that I can combine. Are there any like terms? So are there any 3x squared terms that I can either combine or cancel this with? And no, there are none. 6x plus 6xh, are there any other xh terms? No, there is not. Are there any other h squared terms? No. 3xh. Okay, so there's no like terms to be simplified here. So I'm going to move on to my next step. So that was just doing this portion of it. And now I want to combine that result with the original f of x function. So now I'm going to take what I already have and combine it with by subtracting f of x from it. Right, so if I'm going to subtract f of x, let me use a different color. I'm going to have to change the sign of every term of my original function because it says I'm subtracting f of x. So if you can just picture doing minus this whole quantity, then that negative would be distributed like multiplication of a -1. So another way of saying, another way of doing that is just to make sure you change the signs of each one of the terms. So I'm going to be subtracting 3x squared from my f of x plus h. So I'm going to go ahead and subtract that right here, and you can see that it's going to cancel. And then I'm going to subtract 3x, and I can do that right here, and that will cancel. And I'm also going to subtract 5 right here, so that will cancel. So now this result f of x plus h minus f of x, I'm about to put that over h. So I can take what's left over here, 6xh plus 3h squared plus 3h, and all of this over h. And finally, I will cancel out anything that I can, and I can cancel out an h from each term. And the only reason I can do this with remember, terms are separated by pluses and minuses. So when you have multiple terms in your numerator and a single term in your denominator that you want to try to cancel with anything up in the top, you have to be able to divide that single element into all of the terms in the top. Right? So another way of looking at the top, you could factor out an h, like reverse distribution. So I'm going to factor out h, and then I'll have 6x plus 3h plus 3. All over h. And that will cancel, that little h will cancel. And so my final result is 6x plus 3h plus 3. That is my difference quotient, and I'm finished with the problem now. That's it.